Hey guys, what's up? It's Leaf from Coding with Leaf, and today we're going to be talking about how we can finish problem number 7 from Leetcode using the Rust programming language. I think this is a really nice programming problem to be solving. It's a nice algorithm because Rust actually offers us some great tools to figure out the intricacies of this problem. So let's read through it. Given a signed 32-bit integer x, return x with its digits reversed. So it's going to be a simple integer reverse problem. If reversing x causes the value to go outside the signed 32-bit integer range, then return 0. So we have a couple examples here. The first one is going to be the integer 123. The signed integer 123 is going to be 321, and the signed integer negative 123 is going to return negative 321. With 120, it's going to be 21. And with this final example here, this large integer starting in 153, when reversed, actually goes outside the memory constraints of a 32-bit integer. So in this instance, we're going to be returning x. So this is going to be the intricacy of this programming problem. And Rust gives us all the tools we need. In fact, it gives us quite literally a 32-bit signed integer type. So let's make the function signature. The input parameter is going to be of i32, and the output parameter is also going to be of i32 because we either return the number or we return 0. So let's just quickly return 0 to get this function signature all working and syntactically correct. Now we're going to create another function. Let's call this reverse. It's going to take an input that is mutable, and it's going to be of i32. And as you can see from the function signature, we're going to be using the Option Enum type, and it's going to be wrapped around an i32. And again, the Option Enum is an enum that is used for carrying a sum variant and a none variant. And we're going to use this a little cleverly in our instance because we're going to be using some standard library functions that return a none variant if it goes outside the memory bounds. So let's actually get into coding the actual integer reverse part itself. So as you can see, I'm setting up these 3 variables here. It's going to be the input variable that is mutable, the output variable that's mutable, and a temp variable that's mutable. For this function that reverses integers, we're going to need 3 variables, and they all need to be mutable. And one of them has to be assigned to 0, and the other one has to carry the value that needs to be reversed. So this temp variable is going to just hold a value while we are using this memory. And because of Rust, obviously this memory is going to be freed after the reverse ends. So let's get into writing the actual while loop that is going to adjust these values. So while input is not equal to 0, we're going to be continuously looping, and we're obviously going to change this input value over time. So the way that we actually derive the rightmost value from the integer is by using the modulus operator, and we use mod 10 on input. And we're going to store this value in the temp variable. I'm just going to comment out on the side here so you can see 123 temp is now going to equal 3. So we're going to grab that rightmost integer when using the modulus 10. Now we're going to set input equal to the 1 and the 2 in this instance by dividing by 10. We want to get rid of that 3 in the 123 example, but it's going to be the rightmost, again, the rightmost integer in this integer. So now we have a situation where we have the 3, the rightmost integer, and we have the remainder of that integer stored in input. So what we now need to do is we need to now adjust our output variable to, on each iteration of the loop, add the rightmost to the output's leftmost on the integer. So the way we do that is by multiplying output, first of all, by 10, and then adding the temp variable onto it at the end of each iteration. So this is actually the solution to the problem, and we can just return output at the end of this while loop. But as you can see, I'm actually going to be returning an option enum from this function, and right now we're only returning an integer. Why is this? Well, this is not actually the solution to the problem in total, because we're missing a case. We're missing the case where the integer, when reversed, goes out of bounds for an I32. So how are we going to do this? Well, there's actually some standard library functions in Rust that are going to help us out tremendously here. It is going to be the checked mul and for checked multiply, and checked add for checked addition. And these two functions are going to throw the none variant of an option enum if upon this operation returns a issue. This question mark operator is very helpful, obviously, in Rust because it's kind of shorthand for propagating either the error type or the none type in an option. In a result, it would be the error, and in an option, it would be the none. So in this instance, we'd be propagating up the none to the parent function that is calling reverse. So in the instance where we don't get an issue when we checked multiply and checked add, we are going to return sum with a variant of output. And when we call this function, we're going to use the unwrap or function from the standard library. And in the case where reverse returns none, or the suboptimal variant of option or result, unwrap can be called on option or result, but in this instance it's option, we're going to return 0 as the integer. And of course, this is alongside the guidelines for this problem, where in the case of an overflow, we return 0. And in the case of no overflow, we just return the reversed output. I'm now going to switch over to our lib.rs, which has a module for testing. And under the another test macro, we have the solution for 7. And we're going to write some assert equal statements. And I'm going to speed this up so we can just run through it really quick. As you can see, when running cargo test, these tests did end up passing. They worked for all the regular integer switching, and we also had it for the special cases where we had an overflow. Now I head over to Leetcode, and I changed around the function name a little bit just to conform to the standard. Obviously, it's using an implementation block for the reverse function, but as you can see, it was accepted, and when we submit the code, we actually get a pretty favorable result. Apparently, our code beats 100% of users with Rust. I think that is a bug, but we also have a fairly suboptimal memory usage, but that's okay. I mean, Rust binaries are not known for being small, right?